Hi, good morning. This is Trina here to discuss about electrochemical cell, electrolytic cell, cell EMF and Gibbs free energy. So, I have already gone through the 4 lectures in this module. So, I hope that already you have gone through the study materials. So, here the course page is given. Here the entire study material along with the questions, answers and the solved problems are given. So whenever you join with the given code, that is DMBC, you can access entire study materials. And moreover, if you have any doubt, you can communicate either through my mobile number or through my email ID. These are given in my personal information. So the course chemistry, the subject code is CH101 for odd semester and CH201 for even semester. This course is for undergraduate BTech students and the streams are CSE IT Civil Mechanical for even semester, Electrical ECBME for odd semester. The credits are 3, the contact hours 35 and the weekly I will take the 3 lectures. The prerequisite knowledge required to understand the concept of chemistry, that is the 12th standard. So about the course objective, students will learn the several concepts of chemistry from this chapter, this course. And in the about the course outcome, what we will expect in our graduates. So the students will be able to apply the fundamental concept of thermodynamics in different engineering applications. Okay, an entire lecture plan also given here so that you can understand that which topics will be covered in which day. So I am covering the module 2. This is the use of free energy in chemical equilibrium. Use of free energy in chemical equilibrium. So the first 4 lecture already covered, that is on the thermodynamics. So first you have learned the basic concept of thermodynamics. That is the what are the system, what is boundary, what is the surrounding, and the different types of system, that is the open system, closed system, isolated system. And you have learned the properties, macroscopic properties like intensive properties and the extensive properties. The process, you have learned different process like say the isobaric process, adiabatic process, isothermal process, etc. And in the first law of thermodynamics, you have learned that is the Q is equal to E. It is the internal energy, or it can be represented by U plus W. That is the work done. And also you have learned the enthalpy and the relationship, the mathematical relationship between all these parameters. In the third lecture, you have learned the second law of thermodynamics. You have learned in different way. You also learned the entropy, that is the randomness, and Clausius inequality. In the fourth lecture, you have learned the estimations of entropy, the free energy, and the spontaneity. How we can determine the reaction is spontaneous or not. So now, today I will tell about free energy, EMF, and cell potential. So these are the part of electrochemistry. So it is under the module, the use of free energy in chemical equilibrium. So here is also, we will calculate the potential, the energy. So we can calculate the Gibbs free energy from there. So first of all, we need the idea about the cell electrode, electrochemical cell, electrolytic cell, and we have to calculate the cell potential. Then we can calculate the cell EMF as well, the free energy. Okay, so let's look in the chapter. So one by one, I will discuss all these things. So here, the entire lesson plan is given. Then, first of all, what is cell? I think that you must have some initial idea about the cell. A redox reaction involves the transfer of electrons from one chemical species to another. The energy from a redox reaction can be used to accomplish work by constructing an electrochemical cell. In an electrochemical cell, the oxidation process and the reduction process are separated into two half cells connected by an external wire. The half cell with the oxidation process is losing negative charge, while half cell with the reduction process is gaining negative charge. To maintain electrical neutrality in both half cells, a salt bridge or semi-permeable membrane must connect the two half cells to permit the transfer of ions between the two solutions. Thus, the salt bridge complete the electrical circuit between half cells. Okay, so you understood that what is cell. Now here you can see that it is the electrochemical cell, and I will show the video that how it works. Okay, so it is the electrochemical cell. So zinc electrode immersed in zinc sulfate. It is the anode, and copper electrode immersed in the copper sulfate. So here you can see that is the sulfate. You can see here SO4 minus 2, Zn plus SO4 minus 2. And here you can see the Cu plus 2 and SO4 minus 2. These are remains as ions. Now this is the salt bridge. It is connected. There is the NaCl. Okay, NaCl salt bridge are given. Now the electron will flow from the zinc electrode to the copper electrode. As you are looking at the picture, you can see. And it is a reaction given that zinc is equal to Zn plus 2 electron. So at the anode, zinc will give the electrons. So it will become oxidized. And at the cathode, so copper will gain electron. So the electron, and it becomes neutral. When the copper becomes neutral, it will be deposited, as you can see in this figure, in this video, that it will be deposited on the electrode. Yes, so copper become neutral as it gains electron and it deposited on the copper electrode. So in this way, the electrochemical cell or the galvanic cell works. Okay, so you got the idea, and this is the reaction. You can see that at the anode, you got the zinc is converted to Zn plus 2 and 2 electron, and at the cathode, copper takes the electron and it becomes the neutral copper. So the total reaction becomes Cu plus 2 plus zinc is equal to Zn plus 2 plus copper. Okay, so students, you got the clear conception that how it works. Now look at this picture. So it is the electrochemical cell is a device that can generate electrical energy from the chemical reactions occurring in it, or use of electrical energy supplied to it to facilitate chemical reactions in it. These devices are capable of converting chemical energy into electrical energy. So you remember, so this device capable of to convert chemical energy to electrical energy. Now you can see here the same thing, the zinc electrode immersed in the zinc sulfate. Here zinc electrode immersed in the zinc sulfate and the copper electrode immersed in the copper sulfate. Here the solvent is taken, that is the KCl. Now as I have shown you that electron will move from zinc to the copper electrode and copper Cu plus 2 will become Cu, neutral copper, and it will be deposited on this metal. So the copper will become heavier and zinc will become lighter. So it is the example of electrochemical cell or galvanic cell. And what is an electrolytic cell? So electrolytic cell uses electrical energy to drive a non-spontaneous redox reaction. An electrolyte cell is a kind of electrochemical cell. It is often used to decompose chemical compounds. So electrolytic cell, it is the device used to convert electrical energy of a reaction into chemical energy. That is called, okay, so you understood. Now what is the difference? This is the picture of electrolytic cell. So electrochemical cell convert chemical energy into electrical energy. An electrolytic cell is a type of electrochemical cell in which electrical energy is converted into chemical energy. Okay, just reverse. So electrolytic cell consists of positively charged anode and negatively charged cathode. So let's look what is the difference between electrolytic cell and the galvanic cell. So here you can see the picture. So here it is the iron, that is anode, but in this electrolytic cell you can see the iron, that is cathode. Okay, so iron, here it is anode, and this iron plate is the cathode. But galvanic cell, copper plates on cathode and it is the copper anode. So what are the differences between electrolytic cell and the galvanic cell? So number one, what are the differences? Number one, electrolytic cell, it requires EMF and it produces EMF. Okay. Electrical energy is converted into chemical energy for electrolytic cell. But galvanic cell, the chemical energy is converted into electrical energy. Anode is positive and cathode negative. But here the reverse, anode is negative, cathode is positive. Now oxidation takes place at anode and reduction at cathode. Here for the galvanic cell, oxidation takes place at anode and reduction at the cathode. Okay, so as you've seen that zinc becomes zinc plus 2, that is the oxidation. It occurs at anode, and the reduction, that means copper reduced, Cu plus 2 reduced to copper, that is occurs at the cathode. Discharge of ion occur at both electrodes. Discharge of ions occur only at cathode. This is the non-spontaneous reaction occurs, that is spontaneous reaction occurs. These are reversible, this may be reversible. So flow of electron is from anode to cathode. Here the flow of electron from anode to. Okay, now you can see anode to cathode. Electron, the last point, electrons leave the cell at anode and enter the cell at cathode. And here electrons leave the cell at anode and enter the cell at cathode. Okay, so I hope that you have understood the differences between the electrochemical cell and the galvanic cell. Now, what is the cell EMF? The electromotive force, EMF, is the maximum potential difference between two electrode of a galvanic or voltaic cell. This quantity is related to the tendency for an element, a compound or an ion to acquire or release electrons. Okay, so what is electromotive force? You have understood, that is called as EMF, is the voltage developed by any source of electrical energy such as battery or dynamo. It is generally defined as electrical potential force or EMF. So now how we can calculate EMF? So here what is the electrode potential? We have to first see the electrode potential, then the difference of electrode potential, that is the EMF I have told you. So electrode potential, when a metal electrode is immersed in a solution containing its own ions, a potential difference is set up across the interface. So this potential difference is called electrode potential. Okay, so you have understood what is the electrode potential. Now, if say the electrode potential is given, we can calculate EMF. Okay, so it is the electrochemical series. So electrochemical series is very important, that you can understand that which one will be oxidized and which one will be reduced. That means which will be the anodic part and which will be the cathodic part, you can understand. So the standard potential values of different metal are calculated and arranged in the increasing order of potential. We obtain the electrochemical series. Okay, so the electrochemical series table shows the arrangement of few elements based on the increasing order of their reduction potential. So lithium usually has the least reduction potential, and fluorine has the most. Hydrogen has zero reduction potential. This is because all other elements are compared against hydrogen to obtain their standard electrode potential. So look at the table here. So you can see the left side, it is the written that is the increasing oxidizing strength. Okay, so in this way it is the increasing oxidizing strength, and this is the way of decreasing oxidizing strength. So here you can see the zinc is here, Zn plus 2 electron, and we get Zn. So it is the increasing oxidizing strength. So oxidizing strength is lower for zinc than copper. So here we get the copper. Okay. Here we get the copper. Okay. And here we get zinc. So copper is in the list above than zinc. So its oxidizing strength is higher. Okay. Now, how we can represent the electrochemical cell? So how we can represent? An electrochemical cell can be represented by using special notation. So you look here, you can understand very well. The above given Daniell cell can be represented as follow. So first we will write the part of anode. Okay, so that is the zinc metal and zinc plus 2. So from zinc we are getting zinc plus 2, 1 molar solution, then you get this, and the next half we write the half of the cathodic part, that is the Cu plus 2 to Cu. Now if we break, then the left side cell will be represented as this one, Zn plus 2, and 1m is the concentration I told, and the right side will be represented as the Cu plus 2, 1 molar concentration, and it will be converted into Cu, so that we can understand that what was the initial ion and what is the final ion. So these two half cells are combined using the Sol bridge. Okay, so Sol bridge is represented here using two vertical bars. So it is the combined representation of a cell. Now the finding the cell potential of a electrochemical cell. So by taking account into the oxidation potential of anode and the reduction potential of cathode, then what to do? By considering the reduction potential of both the electrodes. By taking the oxidation potential, so these are the steps we have to maintain. 1, 2, 3. So by taking the oxidation potential of both the electrodes. Okay. So now the standard cell potential delta E0 of a galvanic cell can be calculated by considering the standard reduction potential of two half cells. Okay, so we can write that the total cell potential is equal to the potential for the cathode plus potential for the anode. So this is the equation. So for in case of Daniell cell, what is the equation? The cell potential for galvanic cell, it is very important. You note down this one, it is very important. That potential of the half cell on the right side, the cathode, minus the potential of the half cell on the anode, left side. So by this equation, we will calculate the electrode potential, the cell potential. In case of Daniell cell, the cell potential of Daniell cell is equal to E cell is equal to E for copper. Okay, potential for the copper, it is the cathodic part, minus the potential for the anode, that is the zinc part. So it is very important. Now we will solve the problem, then you will be very clear. So these are the solved problem. Here you can see the first problem. Calculate the EMF of the below redox reaction. So the reaction given here, you can see that is the Mg plus 2 hydrogen H plus, that is the aqueous, and Mg is a solid, is. Then we get Mg plus 2 aqueous and hydrogen gas. So in the first step, we have to break this in the anode and the cathode part. Okay, so you can see here that it is the reaction. So which one is the anodic part, which one is the cathodic part? So first break the reaction into oxidation and reduction cell reaction. So first the hydrogen H plus becomes H2. So it is the part of reduction, as it takes electron to form hydrogen gas. Next, you can see the magnesium converted to Mg plus 2, magnesium to Mg plus 2. So it gives the electron. That is why we can say that is the oxidation reaction. So in step 2, we have to find that standard reduction potential of half cell reaction. So this I will explain in the next lecture. Now you think that it is given for you, that electrode potential for the reduction is given, that is 0.000 volt, and for the oxidation, that is minus 2.372. Okay, now how to calculate? You know that E oxidation minus the E, you go to the first reaction. So it is written that is the potential half cell for cathode minus anode. So at the cathode there is the reduction. So it is the reduction minus oxidation. Okay. So first we take the reduction, that is 0. So 0, it is the reduction, E reduction. Here you can see the reduction, that is the 0, minus, so there is 2 minus 2.372. So here it is basically is equal to, here you have to write is equal to 0 minus bracket, so minus 2.372. Then after this you will get the next step, that is the 0 plus 2.372, and that is the answer. So the EMF of the redox reaction is 2.372 volt. Okay, so next is the consider another reaction, that is the silver plus cadmium, and we get Ag plus 2, we get Ag. So you can tell that is a reduction, that silver is reduced and cadmium is oxidized. So as you know, what are the what are the part that is the consider a half cell reaction. First of all, we have to consider these two reaction. So first reaction, that is the silver plus electron, we get the Ag plus electron, we get neutral silver, that is the reduction, and the reduction potential given here, that is 0.8 volt. For cadmium, that is the oxidation as it release the electron. Okay, so here it is given minus 0.4. So first you have to take the reduction. Okay, that is reduction is value is given, that is 0.8 volt, and for the oxidation the value is 0.40 volt. So now what is our formula? As per our formula, we have to write here first reduction, that is equal to, we can write E reduction, that is the 0.80 volt minus, again minus 0.40 volt. Okay, now you will get the next step. Okay, now you will get the next step, that is the 0.40 volt plus 0.80. Okay, so it is basically, you write here, that is equal to plus 0.40 volt. Then you will get, that is equal to the 1.20 volt. So now in this way you can get the total EMF of the redox reaction. Okay, so if I summarize what you have learned today, you have learned lots of things. You got the idea about the cell. You have learned that the electrolytic cell and the electrochemical cell, and you have learned their differences. You got the video for the galvanic cell. You got the Daniel cell, and also you have learned to calculate EMF if the electrode potential is given. So there are two electrode potential for the cathode and anode. So you have to combine these two electrode potential, then you will get the electrode potential for the cell. Okay, so I hope that you have understood everything. You have enjoyed the class. So go through the material, and I have given more assignment, more problems to solve you. So you try to solve. If you have any problem, you communicate with me. Now I will tell about the Gibbs free energy. What you have learned in the thermodynamics part, that what is Gibbs free energy. So for the cell, the Gibbs free energy for cell, that is minus NFE. So if we can calculate EMF, that is EMF, then we can calculate the Gibbs free energy for cell. Now for a galvanic cell, if the Gibbs free energy is greater than, that if the E for cell is greater than 0, we can say the process is spontaneous. And if the cell, if E is less than 0, so the process is non-spontaneous, that is the electrolytic cell. Okay, so now I am ending my session, and I will tell elaborately about the cell EMF and the Nernst distribution law in the next lecture. So thank you everyone.